This is the second part in the oil furnaces lecture for heating fundamentals. We left off at the oil pump, and that's where we're going to continue. The rotary-type fuel oil pump we had talked about in the first lesson is a single-stage pump. It handles inlet vacuums of 7 inches mercury for single pipe systems. For a 2-pipe system, the inlet vacuum is 10 inches of mercury. When fuel oil is subjected to a vacuum in excess of 10 inches mercury, it starts to come apart. At 15 inches mercury, it becomes a mixture of foam and clean oil, which does not burn well. The gear-type fuel oil pump is also a single-stage pump. The fuel enters the unit and fills the front chamber. The rotating filter blades filter the oil as it passes the front chamber to the suction side of the gears. Oil goes from the lower suction side to the upper pressure side of the gears and flows into the valve. At a predetermined pressure, the piston moves. Oil flows out the nozzle port. Surplus oil returns to the front chamber through the surplus return passage. Oil lubricating the internal shaft and seal also returns to the front chamber through the seal drain. The 2-stage pump is ported so that at 15 inches mercury, the second inlet is submerged in clean oil. Intake from the tank is at the top. Oil passes through the first stage of the pump and into the regulator, and then back to the tank. The second stage removes only oil from the strainer chamber. Oil is pumped into the nozzle. Excess oil is returned to the strainer chamber or tank. With nozzles, we have 2 types of nozzles. The 80-degree types provides a hollow cone spray pattern, the capacity of 0.75 gallons per hour to 1.75 GPH. Another type is the 60-degree type, the hollow cone type. Its capacity is again 1.75 GPH to 12 GPH. The nozzle line heater may be used to maintain oil temperature and viscosity during the off cycle. Oil is heated to about 120 degrees or 130 degrees at the oil nozzle and improves ignition and combustion. Gun-type burners usually use electrical ignition. Systems include a transformer and 2 electrodes. The transformer is mounted on the oil burner, and it transforms 120 volts AC to about 10,000 volts. The newer systems are running closer to 20,000 volts. The ignition system must raise the oil temperature to 700 degrees Fahrenheit for burning to occur. The stainless steel electrodes are mounted in ceramic insulators. No part of the electrode should be closer than 1/4 inch to any metal part, or the ignition spark will go the wrong direction. The electrode ends are positioned in front and above the nozzle. Atomized oil swirls out of the nozzle, mixing with turbulent air. At the same time, a spark jumps between the electrode ends and ignites the mixture. Ignition may be continuous while the burner is in operation, or only until the fuel ignites. The electrode gap should be between 1/8 of an inch and 3/16 of an inch. Electrode ends should be between 1/2 an inch and 5/8 inch above and 5/16 to 1/2 an inch in front of the nozzle. Again, the service manual for the specific burner will give you the exact specifications. Porcelain insulators must be clean or the high voltage will short. The spark should jump at a 1-inch gap with the blower off. You can use testing instruments to check the transformer, and a flame inspection mirror can be used to observe the ignition and the spray action. Make sure the inspection mirror is made of metal and not of plastic. Puffback is the ignition of a large amount of vaporized oil in the fire pot or the chamber. This may blow the furnace room door open or into the living quarters. The causes of delayed ignition and puffback are weak ignition, wrong position of the electrodes, poor insulation. Be certain electrode ends do not touch the oil spray or they will become carbon coated. Moisture in the oil will retard combustion and may cause flame out. If flame out occurs, combustion stops, but fuel continues to feed into the combustion chamber. If moisture causes poor combustion, continuous ignition is recommended. The primary control has 2 main functions. It provides a means for operating the unit. It receives a low voltage signal from the room thermostat, causing the burner motor and the ignition transformer to operate. It also has a safety function. If the burner does not ignite or if the flame is extinguished, it trips the primary relay safety switch. The primary relay must be reset manually. Install oil burners with care. They need to be level and installed according with manufacturer's instructions. The complete installation includes a 200-gallon to 1,000-gallon oil tank, hand shutoff valve, filter and trap combination, and copper oil tubing. This installation pictured here is for a one-pipe system. The storage tank is located in the room with the furnace. Oil feeds by gravity to the oil burner. The storage tank should be less than 25 feet above the burner to keep the line pressure below 10 psi. The storage tank must be at least 7 foot from the furnace. The storage tank may be placed inside the building, either above ground or underground. Some local codes allow only 3 psi to 5 psi pressure at the pump inlet. The two most common installations of oil tank is to place the oil tank above the oil filter, as in the basement, or placing the tank below the oil level, as in a home without the basement. Placing the tank above the oil burner, as in the basement, as in this picture, or below the oil burner, as in an outside oil tank without a basement. The oil tank should always be within reasonable distance of the oil burner. On runs of 50 to 100 feet, 3/8 inch tubing should be used. For runs of 200 to 300 feet, we need to go up to 1/2 inch tubing. Check the manufacturer specifications to see if the oil must be raised above the tank. Oil tanks should be installed with a slight slope away from the oil line connection to provide a low spot in the tank for dirt and water to collect. A vent pipe is also important. It provides atmospheric pressure to inside the tank. It permits volatiles or gases to escape, and it must be designed with a 180-degree bend to keep out dirt and rain. It must have an opening above the highest possible snowfall or any other blockage. The oil fill cap should always be in place except when filling the tank. This keeps the oil clean and reduces chances of explosion or fires. Be certain no water can seep into outdoor tanks. A gasket around the plug should prevent water seepage. The plug and gasket must be tight and in good condition. The vent pipe must have a shielded cap. It must be located above snow lines, away from gutters and downspouts, and away from roof edges. Pipe fittings for underground tanks should be sealed with temperature-resistant compounds. Never use Teflon tape. During installation, keep the tubing ends sealed with tape to keep the dirt and moisture out. Remove the tape when connecting the tubing. The 3/8 and 1/2 inch copper tubing is attached to fitting with standard SAE 45-degree flares. Check both above ground and underground tanks yearly and prior to each fill-up with water finding paste. This paste changes color if water is present. Pump out any accumulations. Replace a leaking tank in accordance with local codes. To avoid water accumulation inside tanks due to condensation, paint the tank silver to reflect sun's rays and reduce thermal expansion. Locate the tank in a shady area if possible. Install the tank so the fill pipe end is pitched facing downward. Keep the tank filled during warm weather to reduce airspace at the top and minimize condensation. Mount the oil line in the tank so that the tubing opening is 3 inches to 4 inches above the bottom of the tank. If a return line is present, it does not need to be near the bottom of the tank for number 1 or 2 oils. However, it should be within 4 inches to 5 inches of the tank bottom for heavy fuel oil, keeping the oil more fluid. Never use compression fittings with fuel oil systems. Again, oil burner installations must be in accordance with local codes and meet manufacturer's instructions. The burner must be the correct height above the bottom of the combustion chambers. Burners are mounted on adjustable legs or on flanges bolted to the furnace. The burner air tube and nozzle must be inserted into the combustion chamber the exact distance per manufacturer specifications. The openings to the furnace must be carefully sealed to prevent air leaks. The nozzle must be of correct size and in good condition, and the nozzle orifice, that's the hole size and the amount of oil pressure, determine the rates at which the fuel will burn and the amount of heat is produced. The size of the nozzle must match the heating requirements of the space. If the nozzle is too small, the space will not be heated. If the nozzle is too big, the burner will turn on and off frequently and decrease the life of the equipment. Nozzles are supplied with a filter element at the inlet to stop dirt from entering. Do not twist the tube or move the nozzle out of line. Use a nozzle tube socket wrench and handle. Prior to starting the oil burner, remove the air from the lines and pump. A vent plug or an air bleed fitting is mounted in the pump housing, seals the port that's used for the pressure gauge installation. If enough oil and air collect in the combustion chamber and ignite, anything may happen. There may be a puff, flame, or explosion. An explosion may be forceful enough to wreck a building, maim, or kill. Inspect the fire pot. If oil is present, shut off the oil valves and vent the combustion chamber. Remove the oil using a suction pump, rags, etc. Remove the oil until all danger of oil fumes is gone. Use an explosion-proof flashlight. Air in the oil line will form bubbles that may result in oil not being pumped, blowbacks, and flame failures. The line must be completely purged of air. A two-pipe system reduces the chance of air remaining in the system, yet air may be trapped in high spots in the line. A leak in the oil line will almost always cause air in line troubles. Always check and confirm the correct size of fuel oil nozzle. Be sure it is in the center of the gun air duct. Electrodes must be kept clean and in correct relation to the nozzle. Nozzles come in various capacities. All are based in gallons per hour at 100 psi. Capacities general range from 0.4 to 28 GPH. However, some nozzles can feed 100 GPH. A 1 GPH nozzle delivers 140,000 BTUs per hour. If the overall efficiency is 60%, the useful heat is 84,000 BTUs per hour. Poor oil delivery may be due to clogging in the main filter, pump, or nozzle filter. Flame failure may be caused by an empty oil tanks that are not vented, clogged filter and oil lines, ice in fuel lines, loose oil line connections, dirt in the supply line, water in the supply line, loose wiring connections, motors not running, a defective pump, pump losing prime, or change of low pressure at pump, or a clogged nozzle. Could also be caused by a damaged nozzle or improperly bypass plug. No spark at electrodes. You might have loose wiring, bad transformer, low voltage, crack in electrode porcelain, electrodes carbon, electrode spacing too far apart or too close together. A proper flame is luminous yellow. If there's insufficient air, the flame is dull orange or red. Smoky tips to the flame indicate a properly adjusted flame. The draft in the fire pot is measured by air pressure drop in the fire pot. It should be about 0.02 to 0.05 inches water column negative from the room pressure. In other words, it should be under the room pressure. Used an incline manometer. This check will also analyze automatic draft. Some oil burner motors are reversible. Make sure that they are blowing in the right direction. If your pump is trying to put out oil through the suction side rather than suck it in, your burner motor's backwards. Inspect electrode wires. If cracked or brittle, replace the wires. Inspect the electrode ceramic insulators. If cracked, replace them. The more frequently unit starts, the greater quantity of soot is deposited. A correct size oil burner will operate less frequency and deposit less soot in the furnace and stack. If the oil line is dirty or clogged, blow it out with nitrogen gas. Always use a pressure regulator and a relief valve. Don't use compressed air or oxygen. A violent explosion may result. Again, air contains oxygen. Oxygen supports burning. Oil burner problems, symptoms, and possible causes are given in a troubleshooting outline. First, burner motor does not start and locks out or cycles. Okay, A does not start. Possible relay not closing, safety lockout open, bad relay coil, or low voltage, or an open high limit control. You might also have broken wires. You might have a transformer open. You might have a thermostat open. Stack switch or heating contacts out of place or open. Might be a bad motor overload. If the burner starts but locks out, check fuel to the nozzle. Variety of reasons including clogged nozzles, too low pressures, fuel tank venting, fuel problems. If fuel is coming out of the nozzle but have no ignition, check your electrodes. Make sure the insulators aren't cracked. Make sure the ignition wires aren't worn, loose, or have dirty connections. Make sure your transformer is operating. Primary wires may be worn, loose, or have dirty connections. You might also have low line voltage. If the fuel oil to the nozzle, ignition okay but no flame, check for a clogged nozzle or strainer. Check for a loose nozzle. Check your oil pressures. Check for too much air or too much draft. It may be sucking the flame right off the nozzle. Check for electrodes being in the wrong position. If the flame burns only a few seconds and goes out, the flame sensor is not in the correct position. Your stack switch isn't operating correctly, or the excess of air, or the air is too cold. Flame might also be too lean. Might have to decrease the air or increase the oil. If it cycles but doesn't lock out, thermostat differential is too close. Anticipators and limit switches may not be set right. Might have an overfired nozzle as well. If the burner does not operate correctly, you might have soot, smoke, and odors. It could be the wrong oil pressure, could be flame impinging or touching the side of the combustion chamber. You might not have enough draft because of a dirty chimney or draft control being out of adjustment, dirty flues, or combustion or heat exchanger leaks. If there's poor mixing of oil, check that the nozzle is worn. Check oil pressure too low or too high. Check for air turbulence and velocity. You might not have enough air. Puffbacks are caused by water in oil or delayed ignition. Go back and check all your ignition parts and oil pressures and transformers again. Noisy furnaces, loose fan, shutters, worn pumps, dirty strainers, air in the line, might have some transfer line humming, couplings. Look for anything that might make noise. Fuel oil consumption too high, look for bad nozzles, look for dirt, look for poor mixing of oil, check drafts, check for air leaks, check oil pressures, and check to make sure it's not overfired, and you can tell this by high stack temperature.